What's up, guys? Just a reminder what we did yesterday. We looked at right triangles, how to find sides and angles of right triangles using SOHCAHTOA. Um, we also looked at Pythagorean theorem, and today we're going to look at kind of something similar, but specific right triangles, specifically 45, 45, 90, and 30, 60, 90 triangles. So these right triangles have a special right triangle ratio that refers to a relationship between the sides, where the sides have a predictable ratio with one another. And so what we can do with that is we can calculate the missing side lengths easily without needing to use Pythagorean theorem. And here's how that ratio works. You should have learned this at one point in time already. But a 45, 45, 90 has a ratio 1 to 1 to the square root of 2, which means both legs are equal, so the 1 to 1, and the hypotenuse is square root of 2 times the length of a leg. And so this is always going to be the case. With a 30, 60, 90, the ratio is 1 square roots of 3 and 2, meaning the opposite side of the 30-degree angle is the shortest side, and that's kind of where I like to start. And then the side opposite of the 60-degree angle is the square root of 3 times the shortest side, and the hypotenuse is double the shortest side. So we have these two things, and we're going to actually, and in y'all's notes, I want you to label these on the triangles. We'll just call them A for right now because we don't know what they are. So the two opposite sides of the 45-degree angles are A, and then the hypotenuse is 2 times, or square root of 2 times those legs. That's how we write it like that. And we're going to fill in these ratios, this ratio table like so. This is talking about what we talked about. So A in 30, 60, 90 would be opposite of the 30 degree. We said that 60 degree is square roots of 3 times the shortest side. So the square root of 3 times A, or A square roots of 3. And then the hypotenuse is double A. So whatever those are. So we're going to get some practice actually doing some examples here using these ratios. And we're going to talk about approximate values versus exact values. And basically what that means is that when we have a square root in our answer, since some of our ratios involve the square root, we are going to leave it as a square root in simplest form if it's asking for an exact. And the approximate is just if it has a square root. We're going to type it into our calculator just so we can get some context in terms of what those dimensions of that triangle would be. So the special right triangle ratios, we have this. We're given the opposite side of the 30 degree is 8. So I know that's 8. And what I know about the 60 degree, I know it's the square root of 3 times that. So my 60 degree side would be 8 square roots of 3. And my 90 degrees is double the shortest side, so 16. Putting that all together, my side ED is the hypotenuse, and that is just a whole number, so I'm going to write that as 16. And then my side DF, that is opposite of the 60 degrees. So for my approximate value, notice we have 8 square roots of 3. I'm going to type that into my calculator and round that number and as 13.86. On my triangle, I'm going to label that 8 square roots of 3. And then my exact value, I'm just going to rewrite this. So 16 for ED and 8 square roots of 3 for DF. Here we're given the opposite side of the 60 degrees. So we know that our 30 degree is A times the square root of 3. So we can see here that our A value is just 9. Right, if I go opposite, I had 9, and then I did 9 times the square root of 3, that would give me the 60 degree. And once I know A, I'm going to try to find A first, and then I'm going to use A to find the other missing angles, or the sides for the angles. So 90 degrees is going to be double the side of A, so 18. And then I'm going to go fill these out. So side BC is my hypotenuse, which is just 18. And 30 degree, yeah, opposite is that's 9. So we don't really have any square roots as part of what we're finding here. But this would be what we would have just filling in that table. Here we're given the hypotenuse. So I'm actually going to do a little bit of algebra here to figure out what my A is. And the way I'm going to do that is I'm going to set up a little kind of equation. So I know that I can do this for one thing. I don't have this written up here, but anytime maybe you're not given the side opposite of 30 degrees, that's where I would kind of start with. And the way you can do that is if we know that this is the hypotenuse, we can say, well, we know that ratio is 2A, And what is in that spot that we're calling 2a? Well, that's 4 square roots of 3. And here I can solve for a by dividing both sides by 2. And then I get a equals 4 square roots of 3 over 2, which 4 over 2 simplifies to 2. And that's what a is. So that is where I'm coming up with this figure right here. So, and from that figure, I know that the 60 degrees is square roots of 3 times that 30 degree side. And so if I multiply these together, the 2 square roots of 3 times square roots of 3, if I multiply a square root of 3 by square root of 3, that cancels the square root and it just becomes 3. So that's saying 2 times 3 is 6. And so when I fill these in, I'm going to fill in my sides with the actual exact values, but on my approximate values, I'm going to type in the square root things and round those. All right, let's look at the 45, 45, 90. We should be able to look at the other side that's not the hypotenuse and immediately write what that is, because they're both going to be the same thing. And we said opposite of that is going to be the square root of 2 times those. So we have the square root of 2 times my other 2 legs, and we would just write it as 5 square roots of 2. If I type that into my calculator, I get approximately 7.07. The exact value, we would leave the square root in there. Okay, here we're given the hypotenuse. I'm going to find, so we know that the hypotenuse is the square root of 2 times those other sides, so hopefully we can see that it's 15. We could also set this up like an equation. We know that 15 square roots of 2 is our value, and if that hypotenuse is a times the square root of 2, we can solve for a, dividing both sides by the square root of 2. Those are going to cancel those and leave us with a equals 15. Okay, here we're given the side opposite of the 45, so the other 45 is also square roots of 2, and the square root of 2 times the square root of 2 for my ratio for my 90 degrees is just 2. And so when I plug this all in, the approximate value of square roots of 2 is approximately 1.41. The exact value we would leave is the square root of 2. Okay, the unit circle, what is it? The unit circle is because that's kind of what we're leading in with today. The unit circle is a circle with a radius of 1 and centered at the origin. So it summarizes all of these 30, 60, 90, and 45, 45, 90 triangle relationships that exist. Understanding the unit circle is extremely useful for when we evaluate trig expressions. So I'm going to end up asking you things in your tests and quizzes like, what is the sine of 5 pi over 3? And you'll have to tell me what that is without a calculator. And that's what we're going to kind of talk about today. So the unit circle looks like this when completely filled out. Don't get overwhelmed by it, but it looks kind of like this. And we're going to I'm going to show you guys how to use this, what types of questions I'm going to be asking. So eventually we're going to fill this entire thing out. But we're going to focus on learning and understanding the very first quadrant and then going from there. And you can get it. It's part of pre-calc. Kids have been doing it forever, and it's not that bad. So far in this unit, we have determined lengths of a triangle as well as ordered pairs for a point on the terminal side. And then notice around this unit circle, we see these different points that are ordered pairs. So if we can relate that to maybe what we did the day before, where we had a point 0, and then we'll say that this is point P or whatever. You have the terminal side like this. You're given this ordered pair, and you would say, okay, let's draw a reference triangle, and we'll label this thing. And so this is kind of the same type of thing, except with the unit circle, we already know one side of this without being given anything, and that side is always going to be the hypotenuse of this, which is always 1. And then we would also look at how if we're given an ordered pair, we can say, okay, well, that's my x value, this is my y value. So on a triangle, I know that this length right here is square roots of 3 over 2 because that's my x. I've moved over square roots of 3 over 2, and I've moved up 1/2, and that's how I get those ordered pairs. So the unit circle is just a unique type of circle. It has specific angle measurements, specifically the 45, 45, 90, and the 30, 60, 90 triangle. It's kind of embedded all around it. So anyways, let's see. These relationships with the triangles are going to help us construct the unit circle. We'll discuss some tricks that we can use to help us remember all of this, because you do need to understand the unit circle for the test and the entire third quarter. So let's dig a little deeper into that. So since we do have a radius of 1 on the unit circle, it means that all of the following have a length of unit 1. So I'm going to kind of draw those lines on here. Like that would be from the center to the edge of a circle would be 1. So would that, so would that, so would that, so would that, all the way around. All of those have it. That's what makes it a circle, right? The point from the center to any point should be equal distance. So those all have a radius of 1. Since we have established that we have a radius of 1, now let's consider how to determine the ordered pairs. So consider the following. Let's take a look at this. Right. So I've kind of highlighted, I've dropped from that point a perpendicular line to the x-axis, making this reference triangle. And so, and I just picked this one in quadrant 1. This happens to be, if we go back, that happens to be at the 45-degree angle from the x-axis. So from here to here, right, that is 45 degrees. So I'm just going to kind of make that into a reference triangle like so. And once again, this is a 45, 45, 90 triangle. That hypotenuse of this triangle is 1 because that's the radius. So I'm going to make this a little bit bigger. So now this is in your notes, so I want y'all to label this. So given the hypotenuse of 1 for each special right triangle, we're going to determine the other 2 sides and label them on the given triangle. So we just got done doing this with our special 45, 45, 90 and 30, 60, 90. Since this is a 45, 90, we need to understand those ratios, right? We're given these 2 sides we would say is A, and then this would be A times the square root of 2. Type of thing. So erase this. So I'm going to figure out what those other 2 sides are. Here's coming from my little table. So if a square root of 2 equals 1, in other words, what our hypotenuse is equal to 1, I want to figure out what my other 2 sides would be. So I'm going to solve for a to find both legs by simply dividing by the square root of 2. And then here's where it kind of is weird. Like, you don't have to go through and know all this stuff. You're going to recognize these different ordered pairs, and you'll see them all around the circle. But I'm going to show you kind of why we get what it is, why it doesn't look like 1 over square root of 2. And that's because in math, we don't leave square roots in our denominator. We do what's called rationalizing the denominator, and that basically gets rid of our square roots in our denominator. So, and when we do that, we end up multiplying by whatever our square root is, and with the purpose of, the reason I do this is because this number right here, this is a number divided by itself, which is just 1. So I'm not changing the value of what I'm multiplying by. I'm just multiplying 1 over square root of 2 by 1. But I'm doing it specifically as rewriting it as square root of 2 over square root of 2, so that when I multiply the denominator, if I multiply a square root by itself, it cancels the square root. And I get something like this. So this is my A. So now I know my other 2 sides of this triangle. I know that side's square root of 2 over 2, and that side's square root of 2 over 2. And if we look back at our unit circle that I said a second ago, if O is the origin and OP is the hypotenuse, then we look back at our unit circle at what we had over here. My thing's all out of whack.
Bobcats. The buses are here. You need to hustle to the student. You need to get on those buses before they...
Okay, so we'll talk about how to figure out this stuff, but I kind of want to, the purpose of this is I want to show you where this stuff is coming from. And don't worry about anything else on this unit circle besides what we're only going to be looking at quadrant 1 today. So my animations are kind of out of whack a little bit. So that was that 45, 45, 90. Let's take a look at the 30, 60, 90. We actually have 2 of them. We have this one right here, and we also have this one. So one of them is just our reference angle, right? This has a reference angle of 30 degrees, And so that would mean the other angle up at the top is 60. And then this one, excuse me, this one right here, that angle is 60 degrees, right? And then this would be 30. So, and you notice our ordered pairs right here, they're the same numbers, just in a different order. So we're going to see the same thing, but I want to show you all how we can come up with those and how those are kind of derived a little bit. So I'm going to take a look at this triangle with this 30-degree reference angle. I know that the hypotenuse is 1 because that's in the unit circle. And I'm going to label this, once again, my animations are out of whack. We want to label our triangle. These are our ratios for the 30, 60, 90. So if I know that my 90-degree angle is 1/2 and my 30-degree is half of that, the side opposite my 30-degree, then that's just going to be 1/2. So I know my A is 1/2. So if 2A equals 1, then if I solve for A, which is the opposite side of my 30 degrees, that would be 1/2. And if I know that if my opposite side of the 60-degree is A times the square root of 3, then if I multiply that by the square root of 3, I get square root of 3 over 2. So label your 30, 60, 90 like so. And that's where these numbers are coming from. So now that we have determined the sides of the 30, 60, 90 on the unit circle, we should also be able to do the same thing with this triangle as well. And I've kind of already said that. They have the same order pair, just switching orders because the angles switched. And I have a lot of repeats on stuff. Because they are both 30, 60, 90 triangles. The last triangle had a reference angle of 30, and this one has a reference angle of 60. Remember, that's how far away from the x-axis our terminal side is. Okay, so here's what I would have you do in class. I have these cutouts for the unit circle. We're going to start building quadrant 1. And if you're watching this, you can grab, if you're watching this and you were not at school, you can come grab one of these from me and then follow these directions. You need to cut out the circle and use, get a ruler, container that has scissors and markers and stuff like that in it. Neatly cut out the circle and label the X and Y axis. We're also going to label the 0, 90, 180, and 360 degrees on each axis appropriately. So other than that green line that we see right here, because that's not supposed to show up till later, this is what your unit circle should look like after you have this cut out. So we're gonna glue this into our notes, but not yet. So and I want to use black or something kind of dark because there's a lot going on. It would be useful if we kind of color coded some of this stuff that kind of goes together so we can see patterns and whatnot. So I'm going to make all the outside stuff on the axes black. I'm going to label the X and Y axis black. And then I have all my degrees all around that circle. And then I have a cutout, 4 green, 4 blue, and 4 pink triangles. There should be 4 of each color. And we're going to use those to look at they're all basically the same reference angle. So what I want to do is I want to fill in the squares for each one of the side lengths. There's a 45, 45, 90, and then there's the 30, 60, 90 triangles. So in the little squares on there, I want you to cut those out and then fill in the little squares with what sides those would be, which is what we just got done finding. Like the 45, 45, 90, you would have 1 for the hypotenuse and square roots of 2 over 2 for the other 2 legs, and then the 30, 60, 90 do the same thing. Next, line, should say line up your 30, 60, 90 with the reference angle of 30 in quadrant 1. This should be blue or green color. Either is fine. Line it up neatly along the x-axis and the, man, so many typos, and to the origin. So we're looking at this, like lining up your triangle that should look like this. You should have 1 in the hypotenuse, square roots of 3 over 2 and 1/2. And then we're going to take a ruler, and that's where the green line comes from. We're going to take a ruler and we're going to draw a line as neatly as possible, going through the origin, touching the side as close as we can get, lined up on top of each other, and then move the little triangle piece away possibly, and draw a line from one edge of the circle to the other. Man. Repeat this for the 45, 45, 90 and the 30, 60, 90 with a 60-degree reference angle, and we're going to use different colors for each triangle. When you finish, you should have something that looks like this. So I use different colors for each one of those triangles that I laid down, and I'm just basically tracing the hypotenuse, but when I do it, I'm tracing it all the way to the other side of the circle. Our goal is to know quadrant 1 angles in degrees and radians, as well as the ordered pairs. If we can understand quadrant 1 and understand reference angles, then we can determine all parts of the unit circle without memorizing the entire thing. So let's look at quadrant 1 and how to figure out what these are, and we'll start building. This is in your notes, so I just have quadrant 1, so I don't want you to go to your actual, I don't want to go to this thing yet. We'll come back to that. This right here, this unit circle, the big one, we're going to try to make that as neat and as legible as possible. So I don't want to work through that and then make mistakes on have to do that. So I want to try to finalize this. So you should have a quadrant 1 only. And the angles on the unit circle come from the special right triangles. We have the 45, 30, 60, 90, and we should hopefully be able to know. We've already talked about around a circle, like what that would be like, and you can start between, like you should notice that from here to here, our first terminal side is at 30 degrees. 15 degrees past that is 45, 15 degrees past that is 60, and then 30 degrees past that is 90. So we do need to know those 30, 45, 60, 90, just in order. Starting with the X and Y axis, we're going to label the ordered pairs around the unit circle. Since the radius of the circle is 1 and the 0 degrees and 90 degrees, we get the following. So once again, we know that this radius right here, R, equals 1. So we've gone over 1 and up 0. That's where this ordered pair comes from. Furthermore, we also know that on the y-axis, this one right up here, we've gone over to the left or right nothing, but went up 1 because this radius is equal to 1. So we've gone up 1, but moved over to the left and right nothing. Okay, now here's the shortcut. Like we can go through and figure out what those ordered pairs are, like we just kind of showed, doing those, using those special triangle ratios, which you're more than welcome to do. And if you get good and fast at that, great. But there is a trick to kind of figure these out really quick. And I'm going to kind of show you what that is. So the first thing we do is we set parentheses. That should not say that. Hold on. Dang it. We're going to set parentheses at the 30, 60, and 45 degrees. We're going to write parentheses at the end. So when we go back to do this on your final copy, I actually want you to write this on the outside of the circle, like on your actual note page, not on the inside. On your circle, I'm going to have y'all write y'all's degrees, like right here, 30, 40, like on the actual circle, just to kind of keep it nice, because this gets kind of busy. And then these will be on your notes page, not on your actual circle, but right next to it. Because then we're still going to go through and add radians. Okay, where were we? So setting up parentheses, and then from the top down, for our x coordinates, we're going to just number those real quick. 1, 2, and 3. 1, 2, 3. And then now going over from the bottom up, we're going to go up 1, 2, 3 and label them like this. 1, 2, 3. So for starters, the pattern, the special shortcut trick for finding those ordered pairs, the x values 1, 2, 3 from top to bottom, then y values 1, 2, 3 from bottom to top. After we have those done, we're going to take the square root of every numerator and simplify if possible. So, and really, I don't need to say numerator because we haven't made a fraction yet. Just take the square root of every single one of these numbers and simplify it. If you notice, 1 does not have a square root because I've already simplified it. The square root of 1 is 1. The square root of 3 is just the square root of 3. The square root of 2 is the square root of 2, so on and so forth. So if I don't want to mess up my paper anymore by writing this and then having to rewrite the square root of 1 as 1. The square root of 1 is a perfect square, so we're just going to leave that like that. Okay. So take the square root of every number. We don't need to say numerator. I changed the order of my steps from previous years. So, and then after we do that, we're going to write all values over 2. So we get something like this. So we're going to get practice doing these kind of daily, but these are our ordered pairs in quadrant 1. Your Q1 should look like this in your notes. So I do want you to go back and neatly fill out these in your on your big unit circle for quadrant 1. I would like to see different colors on each one of these angle measurements, and I would like to see your degrees not written out here, but inside of here. So right there, and maybe make them on the bottom, 45 degrees, 60 degrees, we can go to 90 degrees, 0 degrees, something like that. And then we'll put the ordered pairs on the paper. So your big circle will be glued on, and then the ordered pairs will be on the actual paper. The angle measurement will be on the circle that's glued into your paper. So something like this. Let me erase my stuff that I've done. So this is what we should have so far. After all of our lines are done, I know it might be kind of hard to see. I don't know if I can zoom in. I don't know if y'all can see that, but it should look something kind of like this. Let's look at the angle measurements for radians in quadrant 1. Okay, so we've talked about degrees to radians. We know a full rotation is 2 pi, so I'm going to go ahead and label that 2 pi at the bottom next to 360. And we've talked about the 90 degree is pi over 2. We talked about that before the break. So if we know that because if a full time around is 2 pi, then half time around is 180, halfway between 0 and 180, or 0, sorry, full time around is 2 pi, then halfway around the circle, like over here somewhere. On the other side of this x-axis, that would be pi. So halfway between 0 and pi is pi over 2. And so to think about this, this is just kind of telling you where this is kind of coming from while I'm getting these numbers the way I am. Halfway between 0 and pi over 2 would give us 45 degrees, right? Which is just pi over 4. And now to find the other ones, we're not going to be doing this every time, by the way, converting these. This is just kind of showing where these are coming from. So, and I'm going to show you a kind of a shortcut for this too later on. I'm going to convert 60 and 30 degrees to radians by multiplying by the conversion factor pi over 180. That gives me 30 pi over 180. Let's simplify that. That gives me pi over 6. And then if we do the same thing for the 60 degrees, that gives me pi over 3. So we should have something that looks like this. So once we have those, we can go back to our unit circle, and I'm going to probably put the angle measurements like kind of inside here, so it doesn't get so cluttered. Like that will be pi over 6, and I'll probably want to make these in the same color: pi over 4, pi over 3, pi over 2. Something kind of like in the middle of those lines or something like that, just so it kind of stays not so cluttered. And then I'm giving this to you because I want you to try to see some type of pattern before we go. But these are the values at these different angle measurements. So what do we notice about how sine and cosine at 30, 45, and 60 degrees relates to the ordered pairs of these angles? So in other words, looking at these ordered pairs, if I tell you cosine of 60 is 1/2, and sine of 60 is square root of 3 over 2. And if I look at these ordered pairs and I say the cosine of 45 is that, and I say look at these ordered pairs and say the cosine of 30 is that, and the sine of 30 is that, then what do I notice about the relationship between those values and the actual ordered pairs? And what we hopefully should observe is the fact that on all of these, our cosines values that I just gave are our x values, our sines are the y values, and then we need to think about what tan is. So when we go around and we write these out, cosine and sine of the angle are just the ordered pairs that we're looking at. So the tangent of that is always going to be, and I'll show you how to kind of find that and why it is what it is. But if we look at this triangle again where I have these labeled, right, and I'm trying to find out, first of all, if I write this out with those dimensions of that reference triangle, I can easily see why sine and cosine are what they are, because if we look at SOHCAHTOA, let me write this up here real quick. So SOHCAHTOA, if I look at the sine as opposite over hypotenuse, well, looking at this 30-degree angle, that would be 1/2 divided by 1, which is just 1/2. And this is a y value. This is how much I'm going up. So that is sine. That is our y. Our cosine is adjacent of this angle of 30 degrees. So adjacent would be this one, square root of 3 over 2 divided by 1, which is just square roots of 3 over 2. And notice where this number is coming from is moving along the x-axis. So that is our x position. So that gives us our cosine. Tangent is opposite over adjacent. So what is that in terms of variables? That would be y over x. So it's just y over x. And sometimes these can be kind of a pain in the butt to solve. That's what I would get. And then if I don't know if I show it here or not. I don't think I do. I don't say what that tangent is, but we'll talk about that here in a minute. But you do need to know these. So sine is always y, cosine is always x, tangent is always y over x. So let's get practice using some of these and figuring out what it is I'm actually doing. So I'm looking at the sine, cosine, and tangent of 30 degrees given the unit circle. So I'm going to be looking at, so when I see the sine of 30 degrees, what we need to be thinking is, when I see the sine of 30 degrees, what we need to be thinking is, what is y? What is y at the 30-degree mark on the unit circle? So that is 1/2. So that is where I'm getting this 1/2 from. Cosine of 30 is saying let's go to the 30-degree mark again, and this is telling me look at x, because cosine is x. And so I get square roots of 3 over 2. Tangent is saying go to the 30-degree mark on tangent of 30 and do y over x. So let me show you what this algebra looks like. So anytime I see a fraction divided by a fraction, I always immediately write it as the first fraction, so my y value of 1/2. And instead of doing divided by square roots of 3 over 2, I just automatically write it as multiplying by the reciprocal, because that's how we divide fractions. And then when we do that, the 2's are going to cancel, and we get 1 over square roots of 3. And we've already talked about rationalizing the denominator here. So when I rationalize the denominator, I'm going to multiply by square roots of 3 over square roots of 3. So that square roots of 3 times itself in the denominator will get rid of the radical, and we'll end up with this. So the tangent of 30 degrees is square roots of 3 over 3. Okay, let's look at some other examples around here. So looking at our unit circle, if we look at the cosine of 45 degrees, we are looking at locating the 45-degree mark. Both ordered pairs are the same thing. They're both square roots of 2 over 2, but we're looking specifically at the x one. If I look at pi over 3, that's going to be my last mark, my 60-degree. So sine is y. So in my head, this is how I'm doing it. No, you can't see it, but I'm thinking about, and this is what y'all need to be doing eventually, is when you're doing something, just kind of sketch it out, and you'll get comfortable with this, but like 1, 2, 3, 1, 2, 3, and you know that the 3's have square roots and the 2's have square roots, and they are all divided by 2. So it's like we have something like this, and so this is kind of what I'm thinking in my mind as I'm doing these. I recognize what angle I'm talking about. This one right here is the pi over 3. So if I go there and I know I'm looking for y, then I look at the square root of 3 over 2, and that's that. The sine of pi over 2 is my 90-degree mark, so that's going to be up here. So if that's 0 and that's 1, sine is y, so that's going to be 1. Oops. Cosine of 60 degrees is my x value at 60 degrees, that would be 1/2. Tangent of 60 degrees is going to be y over x, so I have square roots of 3 over 2 divided by 1/2. So y divided by x. I'm going to multiply by the reciprocal. The 2's are going to cancel, and I'm going to have square roots of 3 over 1, which is just square roots of 3. The tangent of pi over 4 is looking at the square root of 2 divided by itself. That would just be 1. Anything divided by itself is 1. And the tangent of pi over 6, that is our first terminal side on the unit circle. If I do 1/2 divided by square root of 3 over 2, I'm going to multiply by the reciprocal and rationalize the denominator. So I would get something like 1 over square roots of 3, and I would multiply by square roots of 3 times, or over square roots of 3. Those are just going to give me 3, and 1 times square roots of 3 is square roots of 3. All right, let's look at the axes, kind of around the axis thing. So I'm going to kind of label these real quick, and it would be helpful if you kind of did this as well. Like the quadrant 1 and then around the axes, you should definitely know. If I go over here to this 180 or pi mark, the x value is -1 here because I'm in the negative direction. And this will be, the y value to be -1 down here because I'm in the negative y section. So the sine of pi is going to be over here. Sine is talking about the y value, so that should be 0. Cosine of 3 pi over 2, that is this area right here. Sine is the x, cosine is the x, so the x value at that order pair is 0. Tangent of 360 degrees all the way around the circle, that's talking about this. We do y divided by x, so 0 divided by 1 is 0. And then tangent of 90 is talking about this one. Y divided by x is 1 divided by 0, and that is a no-no. We cannot do that, so that is undefined. We can never divide by 0. So tangent of 90 is undefined. Okay. I'm pretty sure I already had this page up somewhere. Yeah, I have. Okay. All right, guys, and then we have some practice that goes along with this. I don't know what that looks like yet because I haven't got that far, but this is kind of our notes over this unit. Good luck. Make sure you ask questions. I know that this is new and can be a little bit intimidating, but it's not hard. You'll get to know it. Trust me.